Great. So this is Cortex Analyst in Snowside, and you might remember this page lives in AIML, and if you scroll down, you'll sort of see this tile Cortex Analyst, which is currently there. And what we have now is a landing page where you can see some of your existing semantic views and semantic models. And let's imagine we're creating a brand new semantic. Well, in this case, let's create a semantic view. As you might remember, it was mentioned in the keynote earlier, Cortex Analyst now supports both semantic models and semantic views. So for this demo, let's imagine we're using the brand new native semantic view. I have a demo, some demo data. I'm going to store it in this database over here. And essentially, this data refers to music festival dataset. And it includes data on ticket sales and merch sales. Cool. So I put in the description. That's the semantic model metadata. This is where things start to look a little bit new. We can now provide context to Cortex Analyst semantic models using this provide context part of the wizard flow. And you'll notice that there's a lot of new types of context you can add. Today, in private preview, we're launching the ability to ingest Tableau data sources. But alternatively, you can also, if you have SQL queries anywhere in your organization, you can manually sort of put them in here. We're also soon including Snowflake dashboards, SQL worksheets, even the ability to put in custom instructions on how the semantic model should be generated. And lastly, also PDF documents. And like I mentioned earlier, Tableau is only one of many semantic layers that we'll want to integrate with, including Power BI, DBT schemas, Looker, so on. I'm a little bit zoomed in here, so I'm going to just so that it's easier to see. But here I have an existing, what's called a TDS file. So a TDS file stands for a Tableau data source file. And it's essentially something you can easily export from Tableau if you're on Tableau desktop. We also do ingestion of TWBX files, which are workbook files that you can also export from Tableau. And you can also just directly upload it here in this UI using the button. But for this case, I actually have this TDS file that I pre-uploaded for this demo. So this talks to the Music Festival dataset. So let's go to the next step. You might remember in the past you had to search through tables to find the relevant ones, and your organization may have thousands of tables. With this new feature, and again, I'm very zoomed in, so maybe I'll zoom out a little bit. For this new feature, we pre-select all of the tables for you, so you don't have to do the work of searching through and finding the tables that you want to talk to. All you do is point it at the dashboard that you want to talk to. So let's go to the next step, which is selecting columns. Once again, we've parsed the TDS file in this case to pre-select all of the columns for you. In this case, there's 41 columns, which is 41 things you didn't have to search for. And I'm going to leave this all pre-selected as is. And we also, as always, include example data in the semantic model. So that's the checkbox at the bottom that can add in sample values, descriptions, and even synonyms for columns and tables automatically. We're super excited to introduce this next step, which is brand new, which is the ability to directly connect Cortex Search Services as part of the Cortex Analyst semantic model creation flow. So over here, we've automatically detected all of the columns which are high cardinality text columns. These are columns that we think might require fuzzy matching based on the type of thing it describes. So you'll notice here there's a customer name, there's an event name. Both of those are things that users might spell or maybe use different versions of those terms when they're actually asking their natural language query. So some kind of fuzzy matching really makes sense here. We've also selected email, which is a high cardinality text column, but I'm going to just unselect that here for this demo since maybe I do want exact matching on email. There's also a bunch of other general settings for search services you can change over here. I'm just going to leave the defaults as is. So what happens when I click save? Cortex Analyst takes about 60 seconds or so to parse the entire TDS file and extract all of the relevant metrics, filters, and other information that it can put into the semantic model. We then also go through your entire query history and see what are the queries that were talking to the tables and columns that you are trying to put into the semantic model, and can we extract those queries, and from there, parse the queries and extract relevant information such as metric and filters. We also suggest adding those queries to your verified queries at the end of your semantic model. The other thing we do is we actually cluster those queries together to ensure you don't have 2 or 3 very similar or super identical looking queries added into your semantic model. So it's a lot more intelligent than just taking the raw query history. You'll notice here that we've created the initial semantic model, and there's a UI that looks a little bit different from what you might be used to in the past. Of course, there's a regular editor with all of the information like before, but what we have new here is the suggestions UI. These are verified query suggestions. These come directly from your query history, and let's click review and take a look at what's in there. We have a new verified query dialog over here, and you can see that there is a actual query over here that came from query history, and we've also done the work to back translate that query and figure out what is the English question that that query was trying to answer. So now you don't have to do any work. All you do is validate that the query looks correct and the question looks correct, and you click save and continue. When you click save, this query gets added right to the end of your semantic model. Hopefully, if the internet's, there we go. So it gets added in there. For the purpose of this demo, before I go through all of the rest of the queries, I also want to show what's actually in the YAML at this point. Let's go through it. So you'll notice, like before, we have all the tables over here and dimensions. We've added in synonyms for all of the dimensions. There are sample values over here, which looked at the columns and extracted the sample values for you. And we've also put in English descriptions. The what's new today is the search services that have been added in over here. There we go. So not only have we put in the YAML for the search service, we've also created the search service for you. So you don't have to go and write painful SQL or go into the search service UI and create them manually. They're pre-created for you. Let's go through, and for the purpose of this demo, I'm just going to dismiss all of the suggestions, so I show you what the empty state looks like. In this case, there's roughly about 10 suggestions. Let's dismiss these. And once you're done dismissing them, you'll notice that your semantic model is ready for optimization. That means that you're in a good state, but we can get it even better. What we do is a 1 to 2 hour optimization process. So we'll use these verified queries at the bottom as an eval set. This is because there's a question and an associated SQL, and you can use this as a gold SQL pair, question SQL pair. And we essentially remove it from the semantic model and use it as an eval set. So can the semantic model, without the verified queries, answer all the questions in the verified queries? Well, we go through it, we run eval, and in cases where we cannot answer the question, we figure out why. Are there metrics missing? Are there filters missing? Or maybe there's just custom instructions missing. All of those are agentically and automatically added into your semantic model to optimize it for your usage data. So let's click Start Optimization. Obviously for this demo, I'm not going to make you wait for 2 hours, so let's save the semantic view. And then, did I save it? Okay. Let's see it. Okay. There we go. Internet's a little bit slow here for some reason, but let's wait for it to load. The question was the 2 hours happens automatically. Yeah, you just click optimize and it does its own thing. And I'm about to show you what an optimized semantic model looks like now. So for the purpose of the demo, I sort of pre-optimize a semantic model, or in this case, a semantic view, to show you what you get at the end. Let's put this. All right. That was from my previous attempts to save the whole semantic model, so you can see how the internet's a little bit slow here. Sort of opening slowly. give it a minute. Well, it does, okay, there we go. So, for the first time now, you get a landing page that shows you that your semantic model or semantic view got a lot smarter. The first thing you see is that we got a lot better on the eval score, up from 63% with your verified queries that we could answer without the help of verified queries, up to 93% in this case. In fact, in practice, many of the times we get to 100% of verified queries. We're able to optimize really, generalize it really well. So to do this, we measured accuracy. In this case, there were 27 verified queries, and we added 189 lines of YAML, and that saves around 5 hours of YAML writing work that you didn't have to do. And it also added 41 optimized descriptions, sample values, synonyms, and custom instructions. Yes? We're using the same questions in the verified queries, but we removed the verified query from the semantic model. So if there's 27 verified queries, that's your eval set, and that's where you get from 63 to 93. But essentially we run the same exact 27 questions before and after. So this actually ran 6 times over and over through all 27 questions in this case. It did 81 LLM API calls, 82 SQL queries were run, and it took an hour and 15 minutes to optimize this particular semantic view. So let's go through. It also shows you some specific examples where Analyst has improved itself. So for example, in the past, it looked at, the question was, what are the total sales for rock music? In the past, no SQL was generated, but now the intent was correctly identified and you get correct SQL. Another example here is where the SQL was actually incorrectly generated. The answer was not right. But after, with the verified query addition, or with the generalized metrics from the verified queries, it was able to correctly answer this question. There's a few other examples here, and we also show the diff. But I think what I'm really excited to show you is a real demo of an example of actual cases where this model can actually answer pretty tough questions. So let's get into it. Let's imagine I am a business user trying to figure out something like how many active customers did we have as of March 15th, 2024. And notice that this is a playground where you can just test your semantic model right here if you've not seen this editor before. So maybe one thing that I'll highlight over here is that in the agentic optimization process, we actually extracted a filter, is active. And we named it over here in the customers table. And this actually is a non-obvious definition of an active customer. It's a customer where they have purchases or open support tickets in the last 2 months, and there's some associated SQL there. This is not something that an average text-to-SQL model without a semantic model with it can really do on its own. But thanks to the optimization process, you'll notice that active customers is correctly defined. We have an exist statement. We look at ticket sales, merge sales, and support tickets over here, which is exactly what you're supposed to do based on the definition of this filter is active. So let's take a look at another case. Let's imagine you're a business user and you're trying to ask something like, are we meeting our support SLAs? Now this is a pretty tough question to ask because most models will not know what the support SLA even is. In this case, thanks to our agentic optimization process, we have added in a custom instruction over here. SLAs for support tickets is 2 days resolution. This came directly from query history or one of the queries from the Tableau dataset. Essentially, in this SQL, you'll notice there's a resolution time less than or equal to 2 days. This is all automatically inferred from your query history or your dashboards. so you didn't have to manually put all of this in. And then let's do one last example. Let's say something that uses a search service. List all the merch that Chris Ben has bought. Cool. This is a tough one, because who's Chris Ben? And is that person even in data? Let's take a look at what Analyst tries to do. So you'll notice that the interpretation of this question looks for the customer Christopher Ben. It's not obvious that the customer Christopher Ben is the one in the data. But when you look at the SQL, it's pretty confident and says c.customername equals customer Ben. This is because we automatically added a search service on that column to do fuzzy matching and retrieve the most relevant value, which was Christopher Ben, not Chris Ben. So this way we get the correct SQL, and Analyst is able to get really high accuracy. Cool, so that's it for this particular portion of demo. Let me get a little bit back to slides. So, what does this mean for you? Well, I guess there's two groups of users. For data engineers, you get to ship semantic models with confidence. So, ultimately, you save not just hours like I mentioned here, but weeks of work by auto-generating semantic models from query history and all the other metadata that you already have. You also reduce a lot of your long-term maintenance costs, because models learn from usage and they surface improvement suggestions automatically. Like I mentioned before, and wasn't necessarily there in this demo, but if you used Cortex Analyst over a period of time, we look at the usage and suggest and verify queries automatically to auto-improve the semantic model as you get more usage. And lastly, you can just confidently scale this up to hundreds of semantic models with scale, with consistency, reuse, and just